Hi, I'm Geoff Scott from the Cornell Local Roads program. I'm the Technical Assistance Engineer here at Cornell Local Roads. And I'm going to show a demo based on our stormwater program. It's basically a demo that describes the effects of land use and how the amount of impervious surface will actually influence how much runoff actually comes off of a piece of property. We've got 4 different categories here. We've got one with a lot of holes in it. That'll represent the forest. And each of these decrease in holes represents an increase in impervious surface or a decrease in vegetation. The next category over here is going to kind of represent the agricultural areas where now you've removed the trees. The idea is that because there's a loss of trees and loss of some of that larger vegetation, what you'll end up doing is have an increase in somewhat of that runoff coming from there. The third category over here is essentially representing residential areas where you've got the lawns that still uptake a lot of that moisture. You've got trees and a lot of that runoff that actually falls is collected and actually absorbed into the ground. But what happens is as you put houses and driveways and various other things that are impervious on the land, there's going to be an increase in the runoff because it doesn't have that opportunity to actually soak into the ground. And the last category we got over here essentially represents commercial areas, similar to the big box stores where you've got large flats of concrete and pavement and that kind of stuff. Essentially the idea that a good majority of that runoff that leaves the site is actually going to be collected into your drainage systems or your stormwater ponds, whatever it might be, but not actually get absorbed into the ground itself. So essentially what we'll do is we'll start off with the forest area. The idea is that a good majority of the water when you pour it through here will actually not necessarily leave the site, but will be collected and absorbed by the vegetation in the soil. We'll step over to the agricultural area. You'll notice as a little bit more actually gets away. We're getting an increase because now there's a lack of trees and a lack of a lot of larger vegetation that would actually uptake a lot of that moisture. Now we'll go over to the next area, which represents the residential area where I mentioned just before that there's an increase in the impervious surfaces due to roofs and sidewalks and driveways. And as we would expect, there's going to be an increase in the runoff from that land. And last but not least, we'll go to the impervious surface, where we would expect a good majority, if not almost all of it. There will be some uptake basically through evaporation, but the good majority of the rainfall and the precipitation that falls on the parking lot, the paved areas, will actually be redirected into some sort of stormwater structure. So now if all has worked well, we'll come around. What we'll see is the green, which is the forested area. As we would expect, a good majority of the moisture would actually be taken up by the vegetation. You can see a little bit of moisture is actually runoff. That's not unusual. We've come to where the agricultural area is. Now we've seen somewhat of an increase in the amount of moisture that's actually leaving the site. And then when you get to the residential, you notice there's a substantial increase of the moisture actually coming off of that piece of property. And that's because of, again, the impervious surfaces, the rooftops, the driveways, the sidewalks. All those things contribute to the moisture not getting into the ground, allowing it to infiltrate in. And then once you get to the commercial area, you can see that a good majority, if not all of it, actually runs off. The idea behind this demonstration is just to represent the fact that as you increase the impervious surfaces, you'll get an increase in runoff.